Good day, this is Basic Calculus, and today we will talk about the U substitution rule for integration. So let's review first the general power rule, which states the indefinite integral of u raised to n with respect to u is equal to u raised to n plus 1 over n plus 1 plus c. The general exponential rule, the indefinite integral of e raised to u with respect to u is equal to e raised to u plus c. And the general logarithmic rule, the indefinite integral of u raised to -1 with respect to u is equal to the indefinite integral of 1 over u with respect to u. That's equal to the natural log of the absolute value of u plus c. So suppose we are given an integral in the form the indefinite integral of f of g of x times g prime of x with respect to x. Okay, so we can transform this into another form by changing the independent variable x to u using the substitution u equals g of x. And in this case, the derivative of u with respect to x is just equal to g prime of x with respect to x. Therefore, the indefinite integral of f of g of x times g prime of x with respect to x is just equal to the indefinite integral of f of u with respect to u. So to evaluate an integral using the chain rule, or the substitution method, or the u substitution, so we will follow the following steps. So step 1, determine the inside function or u and the outside function or du. So let u be equal to f of x, find du, find the derivative of u. Next, use the substitution to transform the integrand in terms of u and derivative of u, and evaluate the resulting integral in terms of u, and substitute the expression back in terms of u to the expressions in terms of x. Let's have an example. Alright, let's have example 1. Evaluate the indefinite integral of the quantity x raised to 4 minus 5x raised to 9 times the quantity 4x cubed minus 5 with respect to x. Okay, so first step in our solutions is to identify our u. So inspect your integrand. If we let the function or x to the 4 minus 5x as u, then we will get the derivative of u as 4x cubed minus 5, in which also that is a part of our integral. So meaning to say, we will let u be equal to x raised to 4 minus 5x. And the derivative of u is equal to 4x cubed minus 5 dx with respect to x. Right? So now that we have identified our u and the derivative of u, then we can now start solving for the integral of our function. So you have here the indefinite integral of the quantity x raised to 4 minus 5x raised to 9 times 4x cubed minus 5 with respect to x is just equal to, going back to our definition of the u substitution rule, we have here the indefinite integral of f of g of x times g prime of x with respect to x is just equal to f of u with respect to u. Therefore, in our example, the integral or the indefinite integral of the quantity x to the 4 minus 5x raised to 9 which happens to be its derivative is 4x cubed minus 5 with respect to x. It's just equal to the indefinite integral of u, which is our u is being raised to 9, okay, with respect to u. So now here, this part we can apply the general power rule. So integrating, we have u, applying the general power rule, that's 9 plus 1 over 9 plus 1 plus c. So that would be u raised to 10 over 10 plus c. Now substitute to your expression the value of u. So we have here x raised to 4 minus 5x raised to 10 over 10 plus c, and that is already our final answer. Let's have our next example. So we have here, evaluate the integral of the quantity x plus 4 raised to 5 with respect to x. So here, we can clearly identify our u as x plus 4. So solutions, we'll let u be equal to x plus 4. Okay, so we know that the derivative of x plus 4, or the derivative of u, is just 1, okay, with respect to x. So we have here the indefinite integral of x plus 4 raised to 5 with respect to x is just equal to the indefinite integral of u raised to 5, okay, with respect to u. So apply the general power rule. We have here u raised to 5 plus 1 over 5 plus 1 plus c. Don't forget, plus c is an essential part of your essential part in integrating. So you have here u raised to 6 over 6 plus c. Substitute your predefined value of u here. So you have here x plus 4 with raised to 6 over 6 plus c, and that's already your final answer. Okay, let's have example 3. Here, evaluate the indefinite integral of 6x squared minus 5 times 2x cubed minus 5x raised to 3 with respect to x. Again, identify your u. So if we let 2x cubed minus 5x to be our u, then our du will be x 6x squared minus 5. So we let our u be equal to 2x cubed minus 5x, and the derivative of u is just equal to 6x squared minus 5, okay, with respect to x. Alright, so now since multiplication is commutative, so you may rewrite your integrand in your in the example as you may switch, okay, the arrangement of the factors in the integrand. So that can be written as the indefinite integral of 2x cubed minus 5x raised to 3 times the quantity 6x squared minus 5, okay, with respect to x. Okay, so that would just be equal to the integral of u, which is our u is raised to 3, okay, with respect to u. So apply the general power rule. We have here u raised to 3 plus 1 over 3 plus 1, okay, plus c. So you have here u raised to 4 over 4 plus c. Substitute your value of u, so you have 2x cubed minus 5x raised to 4 all over 4 plus c, and that's your final answer. Now let's have our fourth example. Evaluate the indefinite integral of x minus 2 raised to 6 with respect to x. So it's very simple. So we can directly identify our u as x minus 2. So for the solutions, let u be equal to x minus 2, and the derivative of u is just 1, okay, with respect to x. So here, start now with integrating. So you have the indefinite integral of x minus 2 raised to 6 with respect to x is just equal to the indefinite integral of u, in which our u here is raised to 6 with respect to u. So apply the general power rule. So you have u that would be equal to u raised to 6 plus 1 over 6 plus 1 plus c. So that would be u raised to 7 over 7 plus c. Substitute the value of u. So you have x minus 2 raised to 7 over 7 plus c. And that's our final answer. Let's have example 5. Evaluate the indefinite integral of u times 2x minus 2 raised to 6 with respect to x. So here, looking at your integrand, you know that when you let u be equal to 2x minus 2, we will get the derivative of u as 2. So for the solutions, we let u be equal to 2x minus 2, and our derivative of u is just 2 with respect to x. Okay, so here. So start now with integrating. So you have the indefinite integral of 2x minus 2 raised to 6 times 2 with respect to x. Again, since multiplication is commutative, then you may just rewrite your integrand. So that's equal to the derivative of u, which is raised to 6 with respect to u. So general power rule, apply it. So you have u raised to 6 plus 1 over 6 plus 1 plus c. So you have here u raised to 7 over 7 plus c. Substitute the value of u. So you have 2x minus 2 raised to 7 over 7 plus c. And that's already your final answer. Now let's have example 6. Evaluate the integral of e raised to negative x with respect to x. Alright, so let's have our solutions. So first step is to identify our u. So we know that this is in exponential form. So we let our u be equal to negative x. And since our u is equal to negative x, then the derivative of u is equal to -1 dx. And since we notice that our integrand is not written in the form g of x times g prime of x, therefore we need to solve for dx here. So solving for dx and using du equals -1 dx. So dx is just equal to du over -1. And so dx is equal to negative du. Now, using the substitutions, we may now proceed into finding into evaluating the integral. So we have here the indefinite integral of e raised to -x with respect to x is just equal to, and since it's just equal to the integral of e, and since our negative x now is u, so we have raised to u. And since dx is equal to negative du, so we have negative du. Taking out negative out of the integrand, so we have here negative times the integrand of e raised to u, okay, du, or with respect to u. So now we are already ready to apply the general exponential rule. So applying the general exponential rule, the integral of e raised to u is just e raised to u. So we have negative e raised to u plus c. And next, substitute u. So you have negative e raised to negative x plus c. And that's already our final answer. Let's have example 7. Evaluate the indefinite integral of e raised to x times the square root of 1 plus e raised to x with respect to x. So in this example, or in this given, we need to rewrite the integrand using rational exponent. So our integrand now will be the integrand of e of x, e raised to x times the quantity 1 plus e raised to x, okay, raised to 1/2 with respect to x. So in this case, we can easily identify our u, and we let our u be equal to 1 plus e raised to x. So let u be equal to 1 plus e raised to x. And since u is equal to 1 plus e raised to x, the derivative of u or du is just equal to e raised to x dx. And now, inspecting our integrand, we can see that the integrand is written in the form g of x times g prime of x. Okay, so therefore we can just move on directly into finding our integral. So we have the indefinite integral of e raised to x times 1 plus e raised to x raised to 1/2 with respect to x is just equal to the indefinite integral of u, in which our u is raised to x, is raised to 1/2, and then with respect to u. So now, finding the integral, we apply the general power rule. So applying the general power rule, that would be u raised to 1/2 plus 1 over 1/2 plus 1, okay, plus c. So we have now u raised to 3/2 over 3/2 plus c. Okay, so we have now simplify our complex fraction, that would be equal to u raised to 3/2 times 2/3 plus c. So that would be 2u raised to 3/2 over 3 plus c. Substitute the value of u, which is 1 plus e raised to x. So you have now 2 times the quantity 1 plus e raised to x, okay, raised to 3 halves, all over 3 plus c. Write your answer, express answer into radical form. So you have now 2 times the square root of 1 plus e raised to x cubed over 3 plus c. And this is already our final answer. Next, let's have example 8. Evaluate the integral of x times e raised to 3x squared minus 1 with respect to x. So, solutions. Identify your u, and we can see here clearly that our u is 3x squared minus 1. So let u be equal to 3x squared minus 1. And since our u is 3x squared minus 1, so our derivative of u is equal to 6x dx. And since we notice here that our integrand is not written in the form g prime, that g of x times g prime of x, then we need to solve for dx. So we need here solving for dx using du equals 6x dx. So dx is just equal to du over 6x. Okay, so we can use this substitutions now to integrate our given function. So start with integrating. You have now the integral of x times the quantity e raised to 3x squared minus 1, okay, with respect to x is just equal to the integral of x, and which x times e raised to u, okay, since we let our u be equal to 3x squared minus 1, times the dx, which is du over 6x. So times du over dx. Oh no, not dx. du over 6x. Because dx here is equal to du over 6x, which is here. Okay, so now we can cancel, or we can divide out x. So we have here the integral of e raised to u, okay, times du over 6. So that will be equal now to 1 over 6 times the integral of e raised to u, okay, du. So now we can now apply the general exponential rule. So the general exponential rule states that the integral of e raised to u is just equal to e raised to u plus c. So you have 1 over 6 times e raised to u plus c. Now substitute your value of u. That is, we have 1 over 6 times e raised to 3x squared minus 1, okay, plus c. Rewrite or simplify, we have here e raised to 3x squared minus 1 over 6 plus c, and that's already your final answer. Let's have our 9th example. Okay, evaluate the integral of x plus 1 raised to negative 1 with respect to x. So, solutions. Here we can easily identify our u. So we'll let u be equal to x plus 1. And since u is equal to x plus 1, the derivative of u is just 1 dx. And since here we can see that our integrand is written in the form g of x times g prime of x. So we can directly solve for the, or evaluate the integral. So you have the integral of x plus 1 raised to negative 1 with respect to x is just equal to the integral of u raised to negative 1, okay, with respect to u. Rewriting our integrand such that our exponent is not negative, so we have the integrand of 1 over u with respect to u. Now we can apply the general logarithmic rule. So we have here the integral of 1 over u with respect to u is just equal to the natural log of the absolute value of u plus c. So we have here the integral of 1 over u with respect to u is just equal to the natural log of u plus c. Substitute now your value of u. So you have the natural log of x plus 1 plus c, and that's already our final answer. Next, example 10. Evaluate the integral of 3x plus 2 raised to 5 with respect to x. So solutions, this is very obvious. We'll let u be equal to 3x plus 2, and since u is equal to 3x plus 2, derivative of u is equal to 3 dx. And since we can see here that our integrand is not written in the form g of x times g prime of x, then we will solve for dx. Solving for dx using du equals 3x dx. So dx is just equal to du over 3. So now we can use the substitutions to solve for the integral. So evaluating the integral of 3x plus 2 raised to 5 with respect to x, that would be equal to the integral of u, which is raised to 5, and our dx is du over 3. So you have du over 3. Taking out the constant, so you have 1/3 integral of u raised to 5 with respect to u. Now you can apply the general power rule, so you have 1/3 times u raised to 5 plus 1 over 5 plus 1 plus c. So you have here 1/3 times u raised to 6 over 6 plus c. Simplify, you have now u raised to 6 over 18 plus c. Now write your substitute the value of u. So you have now 3x plus 2 raised to 6 over 18 plus c, and that's already our final answer. So that's it. That's how to basically apply the substitution rule for integration. Again, you need to check the form of your integrand. If it's in the form f of g of x times g prime of x, then you can just move on into integrating right away. But if it's not in the form g of x times g prime of x, then you need to solve for dx and then substitute. Okay, so I hope you learned something, and see you in our next video.